All right. Three, two, and one. Hey, folks, this is Robert Quinn here, your LinkedIn semiconductor industry content provider, and welcome to the new Movers and Shakers interview series. Today, I would like to introduce Tom Sonderman. Tom is the president and CEO of SkyWater Technology. Tom joined SkyWater in 2017 and has led as an executive ever since, driving the company's success, business transformation, and IDM to a pure play foundry. Tom has leveraged SkyWater as the only US based and US owned semiconductor foundry to expand the company's government business and to focus on retaining a strong commercial manufacturing presence in the US. Tom, welcome to the show. Thank you so much for being with us today.
Hi, Robert. Great to be here with you.
Great. Thank you so much, Tom. Tom, first of all, I'd love to ask you some questions and pick your brain. First of all, I'd like to congratulate you on the IPO at SkyWater and all the recent growth you have seen at your company. And I have seen you on webinars with the President of the United States. I've seen you as actively engaging as an industry advocate. Tom, what excites you about the future of the semiconductor industry, and specifically, what excites you about the local domestic growth?
Yeah, great question. And again, it's always nice to have an opportunity to talk about the transformation that is really going on, in front of our eyes. Not only the transformation in terms of moving beyond the smartphone era and starting to put electronics everywhere. So clearly, everyone has a laptop, everyone has a smartphone, but the connectivity and the movement to AI, autonomous vehicles, a lot of this is driving unprecedented demand. I think that's been accelerated when COVID hit. We're on our way to $1 trillion ecosystem. And what is also happening is the repatriation of semiconductor manufacturing. Obviously, almost going on 2 years, there's been a lot of discussion about what is it going to take to start building more, not only innovation capability in the US, but also manufacturing capacity. And I believe those two vectors are coming together at a time where the US has an opportunity to really reset the playing field. And as we move into technologies like heterogeneous integration, quantum computing, and other, emerging post-Moore's Law technologies, there's a need for a different model. And SkyWater kind of came into existence 5 years ago, pre-COVID, pre-realization about the importance of U.S. manufacturing. But coming out of COVID, we are positioned very nicely to take advantage of these trends. And we're excited to be able to be a leader in this transformation.
Yeah, it's been interesting and watching everything change, and we've seen so much growth in the industry in the last couple of years. It's been really shocking. I always talk a lot about the industry. I always post a lot of information on LinkedIn about the industry, Tom, and a lot of the feedback I get is talking about back end sector. And what are your thoughts about the back end sector of the industry? So much of like where do you see that going? Do you see more of that happening in the United States?
Absolutely. In fact, we have a whole facility in Florida dedicated to heterogeneous integration, advanced packaging. I believe that the industry, frankly, has been struggling to take advantage of a lot of the technologies that have been created over the last decade. If you think about the model, you had, TSMC, of course, they created Info, which served the high-end smartphone space for companies like Apple. And of course, Intel has their own internal technology, EMID, for their, basically advanced packaging, heterogeneous integration solution. And what kind of happened to the rest of the industry is everyone was focused on the OSAT community to really stand up these technologies. And the OSATs traditionally don't have, wafer level manufacturing as a core competency. And so I believe that the movement of a lot of these technologies back into the traditional foundry space is an important, I think opportunity that everybody is recognizing, but also to build a domestic capability for these types of solutions and have not only the wafers fabricated in the U.S., but the final assembly tests all done domestically is critically important. And we see heterogeneous integration really as being a driver in the post-Moore's Law world. If you look at Intel, AMD, Apple, they're all using heterogeneous integration to provide their in-state solutions, and having the ability to offer leading-edge solutions, wafer fan-out packaging, hybrid bonding technologies, other types of interconnect technologies all become a differentiator. And I believe the U.S. can really become a leader in heterogeneous integration because of one, we're really good at creating automated facilities, automated fabs. The fabs of the future will be lights out for technologies like heterogeneous integration. And I believe the opportunity is here for us to not only have a capability in the U.S., but actually lead the world and move. I believe 97% of HI is done in Asia, or done outside the U.S. certainly, and the ability to bring that capability back so there's a complete solution here domestically, I think is going to be very, very important.
I love that you have that solution at SkyWater Technology, and that it is such a big topic. And so many of my followers are saying, "Hey, let's remember this whole back end sector. Yes, we can do the front end of the chips here, but why are we going to send these chips directly out to another country to be, tested and cut and everything and packaged when we should be doing that at home as well?"
Yeah, and it's actually, if you think about it, where we're headed, there's going to continue to be investment in advanced node technologies, but the costs are going up. The cost of a design plus the cost to realize the technology are really creating a bifurcated situation where there's a very few number of companies that can take advantage of the advanced nodes, and there's really only a handful of solutions that require them. And so what I believe see happening in the industry is a lot of companies are going to use HI to get to the end state as opposed to a system on a chip solution that would previously been required. And you're going to see a lot more investment. And frankly, this is where the CHIPS bill becomes critical. We need to see a lot more investment spread across the entire value chain as opposed to all this heavy investment in advanced node to serve a very small number of companies. And really, the companies that even produce those type of chips, you can count on one hand. There's literally three. So yeah. I believe that part of the voice that we're amplifying within Congress and within the Department of Commerce is really pay attention to the rest of the industry. It's been starved for investment, and that's really where the U.S. can gain a leadership role, as I said at the onset, because we're leaving the smartphone era, going into this next wave of computation where a lot of these emerging technologies will become commonplace as this decade unfolds, and we have the opportunity to be absolute leaders in those type of spaces.
That's great. That's great. Well, so I was reading the other day in Barron's, you said that the microelectronics industry underpins nearly every segment of the U.S. economy. Can you explain a little bit more details about that? And where do you see the growth and demand for chips when you foresee do you foresee that leveling off in the future?
Yeah, and you could go back to President Biden's summit in April of last year, where he basically held up a wafer and said, actually, that was a SkyWater wafer.
Oh, really? Oh, cool.
But he said, this is infrastructure, and it literally is. If you think of everything from your home appliances to, the sophisticated servers that process all our data, med devices, the whole kind of paradigm. I call it, silicon's the fuel of the 21st century. And it really is the foundation of everything that we do. There's this migration that's been underway for the last couple of decades to a digital economy. Everything's been digitized, We have, a lot of connectivity. And what we're really doing now is connecting the real world to this digitized world that we've created. And that's why you're seeing this explosion in IoT, where from your phone, you can pretty much do anything. You're seeing the movement where now you can actually have autonomous vehicles because you have the sensing technology to actually drive maybe better than a human, assuming you can solve some of the reasoning aspects of it, of the decision making. But overall, we're moving to the point where electronics are just everywhere. And as a result, they have an impact on national security. We don't just need chips for things that, go to the defense industry, but literally when you think about the automotive industry and how they can't ship a car because they don't have a chip to run LiDAR, or you think about, frankly, the situation I'm in, trying to run a manufacturing company where I can't even get tools that I've ordered because chips aren't available to go in those tools. So we're in a situation where we're literally waiting on chips to make more chips. And I believe eventually things will balance out, but the demand isn't going away. I think there's just a recalibration going on at a macro level. But none of us, I would say, certainly at SkyWater, but across the industry, are really seeing any change in the supply-demand constraints that made everybody believe that everything was always going to be up and to the right. And regardless of what's happening in the stock market, you can certainly say the mechanics of what's happening in the industry, taking the inflationary aspects aside, I still think the long-term demand is absolutely there.
Yes, definitely. And both of us are in the heavily involved in the 200 millimeter sector. I know you've been in the industry probably longer than me, and we've been both been in the industry for quite a long time. But I remember a time when we saw 200 millimeter kind of phasing out. We saw 300 millimeter phasing in, and if you asked anybody in the industry at that time what they thought was going to happen, everybody would have said, well, 200 millimeter will eventually phase out over time, and then we'll see the 300 millimeter kind of come in and be a whole lot more popular. Now today we have gallium nitride, silicon carbide, and all this other photonic type of devices that we're trying to manufacture. And fortunately for us in the 200 millimeter sector, it is all done on 200 millimeter due to the ingots can only be grown in 200 millimeter.
Right.
And so, with this demand, I'd love to hear more about your thoughts on the 200 millimeter sector and where you think that we're going. It's, to me, the 200 millimeter sector is here to stay, and we've definitely ingrained that into everybody, despite the fact that a lot of OEMs aren't even producing the equipment anymore. So where do you see that going with that need? And as you said, you need the equipment to make the chips. So
yeah, it's a great question, and really, when I started my career, we're at 200 millimeter, and here we are. I have a lot more gray hair. So the view on 200 millimeter, and there's a couple of important aspects here. One is clearly you have, call it emerging technologies to 200 millimeter, like GaN and silicon carbide, ones that have been done at 4-inch or 6-inch. And so they're scaling up, and that's clearly an important piece. What Wolfspeed has done on silicon carbide, I believe, needs to happen similarly for 200 millimeter GaN, and obviously that will create a domestic source for GaN at 200 millimeter, and that you can kind of envision that as a new fab. But then you also have a lot of these existing fabs that continue to generate, very profitable products at 200 millimeter. What really drives the industry and drove the industry to 300 millimeter was this movement to more and more, packing more and more transistors in a smaller and smaller space. And so you needed more real estate and the economies of scale to serve, first the PC market, and then the smartphone market kind of drove it. But when you look at all this connectivity we were just talking about, whether it's photonics, superconducting films, a lot of the stuff in the MEMS space. You don't need to have 300 millimeter, especially given how small some of these die are.
Mm-hmm.
So what we really see is 200 millimeter is not only here to stay for certain types of technologies. For instance, we're making, 130 nanometer programmable system on a chip for Infineon that has been made in this fab, for the last 15 years. So, and they're winning new designs all the time. So the idea that 200 millimeter is going away is not going to happen.
No.
But the other thing, and this is kind of the SkyWater angle, is a lot of developments, really is more efficient at 200 millimeter because not only is it cheaper, you don't have to run it in these highly automated fabs that you typically see, and you need them highly automated to get the return on invested capital. So 200 millimeter is turning out to be an ideal node for a lot of these emerging technologies that certainly SkyWater is involved with. And what a lot of our customers tell us is that they've tried developing at 300 millimeter because of the expense of doing 300 millimeter development. You become a very small percentage of the overall output of a fab, and as a result, you get deprioritized, and the development doesn't happen at the right cadence. What we're finding is that being able to do development in a high volume fab, which we can do, certainly we do here at SkyWater, is accelerating our customer cycles of learning. They're getting to market faster. And then when we look at, into the future and, say we build another fab, we would certainly build a fab that would take advantage of 300 millimeter capabilities. But to date, we believe that the right angle for a lot of companies is doing 200 millimeter development. If the technology requires 300, you could move, but the equipment community has also adopted a system approach where they build an overall system and then just pull out the chamber and the handling system, depending upon whether it's a 200 or 300 millimeter, wafer size. So I think the industry is doing what you acknowledge, which is, realizing the 200 millimeter is here to stay, 300 millimeter is here to stay, and we need to make them synergistic so that the customers can get the maximum amount of benefit when they engage with the foundry. And SkyWater intends to have both those capabilities available as we grow and scale over time.
That's great. Yeah. And as I was thinking about it, and I was just thinking about the conversation I had yesterday. I had a conversation with one of the ministries in India. So India is looking at coming online as well in the semiconductor industry. And of course, they're wanting to go 200 millimeter as well. And 180 nanometer nodes and looking at a lot of different opportunities. So that again puts the 200 millimeter equipment at another country needing 200 millimeter equipment. And
that's exactly.
There's so much of it right now that's so much of it has gone to China, and so much of it is then we have some of it in the EU, some of it in the United States. But now we're going to see India coming online with that as well in the near future. So it's interesting.
And I think, again, as companies reevaluate their strategy, I'm talking about equipment OEMs, and look at where the market is going, again, it goes back to the investment. If you think about all the investment that goes in to create, say, a 5 nanometer node across the industry, it's enormous. And there's a lot of other parts of the value chain that don't get even close to that level of investment. So part of the strategy needs to be, how do you get a more balanced input? Again, the advanced node technologies only serve a small percentage of the market, and part of what has made SkyWater a success since we launched 5 years ago was there was a huge appetite for innovation on non-advanced node technologies, and innovation that was, not only available, but kind of what I call the virtual IDM model, where companies could come in and actually build their products while we were optimizing the process like any IDM would do. And as a result, they get a differentiated product that they can bring to the market in an accelerated fashion that allows them to dominate their new market and, have a way to really leverage silicon as a differentiator versus everybody buying the same, basic process technology and having to differentiate purely through the design. There's a
Right.
reason why IDMs were created, because there's a balance between the product development and process development. And that's kind of what SkyWater is bringing to the industry with our technology as a service model.
That's incredible. That's great. I love to hear it. I love to hear that y'all are growing and so much going on with SkyWater. And I was just reading today. Actually, I saw your signature in a letter to the Congress today, and your name in there. It's we're all rooting to hopefully see this growth and this expansion in the United States, and a lot of this funding coming in to feed that growth and to make that happen. So
Yeah, I would say, for all those people listening online, let's make sure that everybody's reaching out to their congressmen and doing, all of our individual parts to amplify the message, that the letter, was put in place, to, get movement, because, if you look at other countries, they're moving a lot faster. And the longer it takes, the more delay that you get to the end state. And I believe that it's a huge opportunity, and public-private partnerships work. SkyWater is a perfect example of one. We have partnered with the DoD here in Minnesota. We partnered with Osceola County and the state of Indiana and state of Florida down at our fab in Osceola County. And as a result, we really have created, I think, a model that shows that there is a way to bring semiconductor manufacturing back to the United States, do it in a less capital intensive manner. And part of it is by spreading the cost not only to, public entities, but also our partners. Our partners engage with us in a way that's very different than the traditional foundry model. And that spreads the risks across all parties. And it's allowing a lot of innovation to occur here in the U.S. that wouldn't happen if SkyWater didn't exist.
yes, definitely. Well, thank you so much, Tom, for joining me today. It's been incredible talking to you. It's such an honor to be able to speak with you and to pick your brain about the industry and hear everything that you're working on. I look forward to seeing you again in the future. Do you have if I have followers or people that are interested in finding out more about SkyWater Technology, is there a place that they can go to? Is there especially about your different types of growth that you have, the changing the ways that chips are being made, and your service models? Is there any more information you can add to that, or how can people find out more information about that?
Yeah, SkyWaterTechnology.com. So, that if you go to the website, there's a lot of information. You can actually, not only learn about SkyWater, but if you want to initiate an interaction with us, you can trigger that off on the website. And, we're on LinkedIn, of course, and that's another place, within the LinkedIn system. We put a lot of information out there. And again, just appreciate the time and your dedication to the industry. You've done a real service consolidating information on LinkedIn. And I think the outreach you're creating and the awareness that is happening as a result is very important, because we're really trying to not only make what's happening with the CHIPS Act a one-time event, but get America rededicated to manufacturing. Great countries manufacture products, and semiconductors clearly is a product that we need to be doing more of here in the U.S. We invented the industry, and we're definitely on our way with the right thinking. And of course, that we have the best talent in the world, in my opinion, obviously, to do it. And by the end of this decade, we'll be well on our way to rebalancing, or what I like to call creating a balanced and secure supply chain.
Yes, definitely. And thank you so much, Tom. And thank you to Move Technologies for promoting this event and promoting the Movers and Shakers interview series. If you are looking for used semiconductor equipment, or if you need to know any information about used semiconductor equipment, Move Technologies is the marketplace for used equipment, and we'll be happy to help you out. Check us out at www.moov.co, or you can check us out on LinkedIn, and I look forward to seeing all of you there. If you have any questions, please feel free to let us know. Thank you so much, Tom. Have a great day, and I look forward to hearing from you soon.
Yep, great. Take care. Be good.
Thanks, Tom.